Hello, my name is Ibrahim Hussain. I'm going to be presenting on the paper Gallbladder Cancer Detection in Ultrasound Images based on the YOLO and faster RCNN models in 2024 by Sarah Dejo, Heidi Sajedi, Tehran, Iran, which is published in 2024, 10th International Conference on Artificial Intelligence and Robotics. So the data is found at this link here, which is found in the paper. It's just ultrasound images of gallbladder cancer from 218 patients. And there's a total of 1,255 images, 432 being normal gallbladder, 558 being benign cancers, and 265 being malignant gallbladder cancer. Training and test sizes were 1,133 and 122 respectively. So this is an example of the images. You can see that it's just ultrasound images of gallbladder, and we're going to use that to detect and classify. So for the models, there's going to be three models. The faster RCNN model, which is just a region-based convolutional neural network, which is going to identify the image with selective search algorithm, and then it's going to apply convolutional neural network at the end for classification. And then you have the YOLO V8 model, which is the YOLO Look Once model. It's just going to do object detection. That's going to use convolutional neural networks by detecting bounding boxes, and then it's going to classify them. And then we have at the end a fusion of the two, which is proposed by the author. And they're going to propose that these, using both of them, the hybrid model is going to actually make up for each of the model's weaknesses. And this is what they're going to ultimately test, and we're going to see if it actually turns out to do better. So this is a useful image of how the hybrid model actually works. You can see that first it's going to go through faster RCNN. It's going to go through YOLO. They're going to make whatever they, the bounding boxes, and they're going to do their algorithm to detect. And then we're going to see if both of the model boxes exist. If they do, then we're going to just retain the RCNN boxes enclosed in a YOLO box center, and hopefully that's going to get a better precision and better accuracy for object detection and classification. If not, we're just going to utilize whatever one box we have. So the methodology, we're going to use faster CNN to obtain the bounding boxes. We're going to pre-train YOLO V8 on the COCO dataset, and then we're going to train it again. We're going to use the Basu et al.'s method to get object detection metrics, and then we're going to use the bounding boxes for image classification, which is just going to use a multi-scale second order pooling, layers. So in terms of the results, you can see that there's, so because we did object detection and we did classification, we're going to have two tables. Top is object detection, bottom is classification. You can see in the object detections that we're actually having a better MIU score with the hybrid model, as well as a decent precision score, not the best, but decent, and a much better recall score. And then in terms of classification, you can see it doing well in pretty much everything: accuracy, sensitivity, and specificity. But there are some criticisms which I'll get to the end. So here are the findings. You can see on the left that the hybrid model is actually doing a lot better than its faster RCNN and the YOLO V8. You can see them actually messing up, but with the hybrid model on the left, it's actually doing really well in classifying these images. That doesn't mean it's perfect. You can see that there's also some misclassified cases on the right, with the yellow being the actual and the green sort of, you can see it not exactly hitting correctly. So I learned that there's more than one methodology to classify images. I didn't know about the YOLO V8 model, and learning about that was nice. I learned that sometimes combining models to make up for one another's weaknesses is a good idea. And I learned that models are not always going to be perfect. Even if you combine them to try to make each other's weaknesses, you're not going to get a perfect model at the end. It's still going to have weaknesses. And then, as I said, this is a possible application in heart scans. With our project, we're doing heart strokes, so if you want to expand it to images, that would also be very useful. So my criticisms, there's no use of the time metric. I say this because I theorize that it may actually take a bit longer. Assuming that we need to check for both boxes for the RCNN and the YOLO V8, I feel that it would actually take a bit longer, so I'd like to see that metric used. I'd like to see a comparison of using other classification and image models other than CNN and YOLO. There's some false positives which you saw in the graph, so there's a criticism there. And I'd also like to see some use of other examples in medical imaging, not just gallbladder cancer detection, but actually, maybe broken bones or things of that sort. Okay. Thank you.